Okay, Jade's new suitcase weighs 3 kilograms. When it is packed, her suitcase must not weigh more than 25 kilograms altogether. What percentage of the 25 kilograms does Jade have left for packing? Well, if the suitcase actually weighs 3 kilograms and the total you're allowed is 25, well then for the clothes or whatever she's going to put in there, okay, it's got to weigh at most 25 take away 3, isn't it? 22 kilograms. Okay, that's the total luggage weight if you want. That she's allowed to have without the case itself. So the case is weighing 3 kilograms. So what percentage of it? Well, it's 22 kilograms out of 25, isn't it? As a fraction. Okay, that's what she's allowed to have. In terms of her allowance, 22 out of 25, that's the fraction she's allowed to have in terms of the stuff she can put in. Okay, so we've got that as a fraction. Now to change into percentage, we often think about timesing it by 100, which would make sense, but in another way, right, a better way in this case is to get the fraction, so that it's out of 100. So if we do that, then we've got our percentage, and I say that because it's easy to change 25, isn't it, out of 100. So you just times it by 4, and then we get 100. Okay, times the bottom by 4, but you times the top by 4, then 822 times 4, you get 88. Okay, so 88 out of 100, that means 88% could be used for packing. Now, for part 2, this is a sort of dimensions, okay, question where they're looking at the suitcase. Okay, and A, B, C are the 3 dimensions of the suitcase. So if you think about it, A, B, and C are sort of representing lengths, aren't they? Okay, if you think about the suitcase, okay, I'm not very good at drawing these here, but if that was a sort of suitcase here, roughly, it could be those are your dimensions there, right? In terms of the lengths. Now it's saying which one of these could represent the volume. Okay, now you might be expecting it to be like A times B times C. Okay. Because that's what you do, wouldn't you, if you had like a cuboid. However, a suitcase isn't actually a cuboid, isn't it? If you think about it, it's got sort of curvy edges, isn't it? Yeah. Okay, and it sort of rounds itself at the top, maybe. So that's why it's the volume isn't A times B times C. Okay. There's a combination of things here, but we've got to decide which one would be relevant here and dismiss the ones that are not. Now, if you look at the first one, clearly, I want you to see here, the first one cannot be allowed, right? Because if you think about here, we've got A, and then adding B squared, add C. Now, A is a length, so you're like adding a length. Now, when you're working out volume, you don't add a length, don't you? And it's the same with C, you don't add a length on. And B squared, well, that's like an area, isn't it? It's like working out the area or something when you square it. So we're adding a length here and an area. It just doesn't make sense. I've drawn this down here, which might help as well to understand. When it comes to length, okay, we just have a single dimension. But when it does come to area, if we had a square, for instance, it would be L squared. You've got 2 letters times together, haven't you? L times L. When it comes to volume, if you had a cube, you times these. So you'd have 3 letters times together. So it's important to look out for that, right? We need to have 3 letters times together for it to be a volume. So instantly we can dismiss this because we haven't got 3 letters times together. Now when you look here, this actually is 3 letters times together because A squared is A times A and then times by C. So you have 3 letters there. But unfortunately you haven't got 3 letters here because you just got B squared, B times B. And pi, right, isn't a letter, it's a number, isn't it? It's 3.14. It's a constant. So it won't work because you've got 3 letters here, but you've only got 2 letters here, so it's inconsistent. The one that's going to give us the answer is this one here, because if you look, you've got 3 letters times together here. You've also got 3 letters times together here, okay? Because you've got A times C. So there's 3 dimensions there, 3 dimensions there. So that's our answer, okay? You can dismiss the others then, because you can see, we've got just a length there. That's no good, and an area there. They've got to be consistently the same, okay? You've got to have 3 letters in each of them for it to make sort of a volume. And when it comes to part C then, okay, when we read here, we've got the passport photograph, and they're similar, mathematically similar. So we're asked to work out the width. Now when you draw this out, it actually becomes really easy because they say the new one is 9 centimeters. Okay, if you change that to millimeters, of course that's 90 millimeters, isn't it? And if you think about it, okay, that is double that, isn't it? Okay, so that side corresponds to that. It's just double it, which means we've just got to double this, and straight away you've got your answer. So the width is going to be 17 millimeters, okay, or 7 centimeters.